Hello everyone and welcome to this video of competitive programming, and in today's video we'll be going through the most important functions in the math library. So basically bits slash stdc++.h already includes cmath.h library, so you'll not be worried, and we'll just jump right into it. So you can perform cos, sine, tan. A cos is basically if you're given the value of cos theta, and if you want to find the value of theta, you can use a cos method. So if you're given a tan, so basically the use of this function is basically if you're given the value of tan theta, and if you want to find the value of theta is how much, you can use a tan theta. While you plug in the value of tan theta is equal to x, then you'll get the value of theta. So that's what the a cos theta. You didn't get it. So basically you have a value of tan theta which is equal to n x. Value of theta is a tan of x. That's what it basically means. Arctangent means that, okay? So you can calculate the value of cos, sine. Here in input you'll be giving radians, and in the output here you'll be getting in degrees is basically it is 2 pi by 180, right? Is it 2 pi by 1? I don't remember. It's not that necessary. So basically you'll give in radians and you'll get it in degrees. So if I just run it here, I'll get the value of cos 0.5 radians, which is 1. Okay, I can do the same for sine as well. I can do the same for sine, which is 0. Sine half is 0. And again tan a cos, as I said you before, if you know the value of cos theta, and if you want to know the value of theta equal to a cos of x. Okay, that's how you do it. That's what it basically means. And this as well, all these functions work like this. It's very easy. You just use the particular function which is provided. Okay, a tan 2xy is when two parameters of the arc are given. No, this is a single parameter. This is using a single parameter. This is using this is using a single parameter, and this is using two parameters. It's very easy. And now coming to cosh. So basically, if you want to calculate angles in a hyperbola, you use hyperbolic functions as like this. So if you want to calculate the angle A, then you use hyperbolic functions for that. Cosh, sin h, tan h, a cosh, a sin, a tan h. It's very simple. And you implement it the same way that you have implemented sin, cos, tan. It gives you the value accurately. Now coming to exponents, epx is e power of x. That's it, khalas. There's nothing more to that. Log of x is again log of x. Simply, if you just write log of x, it will actually give you the answer. And if you remember, in our video of counting digits, log base 10 of a plus 1 is the amount of digits which are present in a number. Amount of digits which are present in a number. So let us let us do it once again here. If I go down, where is this? Log base 10 of x, I'll just plus 1. Let us see the amount of digit that this x has. It has negative infinity. Why is it giving me here? Oh wait, I need to make this a comment. That takes a lot of time again. It's giving me negative infinity here because if you plug in log base 10 value of 0.5, it's not defined. So it's basically giving you negative infinity. Again, I go down, a log base 10 of x, log base 2 of x. This is log base 10 of x, and this is to compute log base 2 of x. exp2x is 2 to power of x. If you want to calculate 2 to power of x, you use exp2x. Let us check it once. If you want to check this, I'll leave a link to this file and you can download this. exp2 power x. And we'll keep x as, let's keep it as 3 or 0.5. 8, that's it. So it is 2 power of x. And then power function POW x comma y, which I've already told you, this is basically x raised to power of y if you're writing this. So if I write POW of 2 comma 3, this will be 2 raised to power of 3, which is 2 cube, which is again which is basically again 8. If you want to do it, you can do it. Square root to calculate square root of x, and then you have cube root CBRT of x to calculate the cube root of x. SQRT CB, cube is CB, RT cube root of x. Okay, to compute hypotenuse, we don't actually need this. So if you have two sides, this is your x and this is your y, and if you want to calculate the hypotenuse, you can plug in the value of x and y and it gives you the hypotenuse. You don't actually need that. And then error and gamma functions, this is fun. If you have studied probability and statistics, you might be familiar with this error function. So it basically looks something like this. Not probability and statistics, calculus for that matter of fact. If you have studied basic M2, you might be familiar, and that's how we calculate the error function. Use ERF of x to calculate the error function in C++. Here is ERF of x, and if I remove the comment, ERF of x of around 3 is 0.009. Wow. So the greater the number increases. If I go 0.5, it is 0. Okay, so that's how you calculate the error function using ER of x. Complementary error function is basically ER of x minus 1 or plus 1, something like that. I don't remember. Yeah, 1 minus that. Okay, so gamma function. If you want to calculate the gamma function, gamma n is equal to n minus 1 of whole factorial. So n minus 1 whole factorial, if I were to find gamma of 9, it's very lengthy, but a computer can do it better than a human. So you have T gamma function, T gamma of, let us take a very nice one, let us take 9. Yeah, 10 is going to be massive. 20. Yeah, it's going to overflow because int is 10 to power minus 9 to 9, so it overflows there. So yeah, more about that. So log of the gamma function, and gamma function is it looks something like this. It's actually PTSD for me. But so anyways, log of gamma function is basically log of this gamma function is what you get here for this L gamma. And then rounding off, reminder, round up value, basically if you're writing 0.9, round up is up to the nearest integer. This is 1. Round down is basically 0. Round to the nearest is basically, if you're 0.4, the nearest to this, if you're writing 0.4, the nearest to this will be 0, so it's 0. But truncate value is basically the same as this, but truncate is used to floating to reduce the number of floating pointers or floating numbers or floating digits or whatever you call. I'll tell it again. Okay, seal is used to round up. Even if you have 0.2, it's going to round up to the nearest integer up, so it's going to go to 1. Seal down, I mean float, it's going to go down. No matter if even if you're 0.9, it's going to give you 0 because it's going to go down one value. Round, it's to the nearest integer. If you're 0.4, it's going to give you 0. If you're 0.6, it's going to give you 1. And then truncate is used to eliminate decimals, basically that. Okay, f mod is basically reminder. This f mod of sorry, I'm really sorry. F mod of x comma y is equal to basically x mod of y. If you're lazy enough to write x mod of y, they have created something for you as well. Floating pointer manipulation, this is used to copy signs. So for example, x is equal to minus 10, y equal to 6, then copy sign of sign of x comma y will give you the output like 10 and minus 6 equal to x equal to y. It does something like this. And then generate not a number value. This is used in AIML basically. This is used in Python, pandas, etc. etc. So don't worry much about this. Okay. Next after represents the next value after 2 and 5. 2 and 5, it's basically 6. It's just incrementing plus 1 and they're making it fancy. Next word is the same. You don't need these two. Again, F is to find the difference, positive difference. So 2 and 5, the positive difference is 3. It basically removes the negative sign. This is used to remove the negative sign. F max, or you can just write max of x comma y. This is used to find the maximum between two numbers. Min is used to find the minimum of two numbers. You don't actually need to write f here. If you write max and min, it works. Okay. And then again, coming to other functions, absolute value, it rounds off. Abstract value also rounds off. Multiply and add, I have no idea about this. And these are constants. Constants basically mean that these are keywords. Just like you have int, right? These are also your keywords. Not a number, not a number, not a constant, and huge value constant. You don't need this. But if you're writing 0 by something, 0 by x is infinity, right? So you can use this constant somewhere to represent this. If x by y is equal to infinity, then I can tell that x equal to 0. You can use that. It's not like you can't use it. You can make use of that, and that's about it. If I execute all these, it's going to take me one lifetime, so that's why I didn't execute. I'm really sorry, but I'll leave the link to this and you can download this and practice it. And that's about it for today's class. Thank you. Bye.